have a short question for you too, so I know about the audience. Who of you is using SQL? Raise your hand. Okay, that makes sense. Who of you is still using Windows 3.1? Really, nobody. Usually there's one claiming. Nobody. Who is still remembering Windows 3.1? Yeah, in your nightmares, I guess. Yeah. It was okay. It was no network, no virus, no nothing. Yeah. Okay. So my talk, Modern SQL, is about the recent and not so recent additions to the SQL standard. So SQL is the language. It's a standard by ISO. There are several versions of that standard, and this talk is centered around these versions of the standard. And I've taken a few interesting features from these standards, and I'm showcasing them to you. So SQL 92 is pretty much the one everybody knows. So if you have learned SQL at university or from a book, what you know is pretty much SQL 92. Not even all of that, but the important parts of that. After SQL 92, the next standard release was SQL 99. And this was already amazing because it broke with the relational model. Again, it broke with the relational model. With SQL 99, some 18 years ago, they already admitted that the relational model is good for many cases, but not for all of them. So they have made some additions. The killer feature was actually the object relational database, which is a killer feature in that sense that it didn't work out. Yet there were some other additions. And I want to show you, first of all, the lateral. Who knows what is lateral? It's a valid SQL keyword, at least in many databases. Yeah? Okay, I will show you the problem it solves. Okay? If you look at this query, it has a subquery in the select list. That's a so-called scalar subquery because it may return only one column and only one row. If you try to select a second column here, you will get a syntax error. If you accidentally select more than one row, you will get a runtime error. Even better. Nevertheless, there are good use cases for this kind of subqueries. And there's now a solution how to lift both limitations, the row and the column limitation. And this is called the lateral derived table. So that's the technical term for it. What does it mean? A derived table just basically means it's a subquery in the from clause, as you can see here. And if you prefix that subquery with lateral, then you are allowed to do a correlation like we did it in the subquery above, in the select list. If you see here in the where clause in the subquery, it says T1x equals T2y, and the T2 is the outside table. This is not allowed with this lateral keyword. So we still have the correlation here, and we can select many columns and many rows. It's just a join now. I've used a left join here, but you can basically use any join here. You can do a cross join, inner join, whatever you like. It has the normal join semantics. And pretty much that's it. That's there now. You can use it. One of the very common use cases for this is the top n per group query. Say you have some groups and you would like to get the best, most recent rows for each group. Then you can basically use that technique like a subquery. Because now you can put the limit inside the subquery, and this limit is only applicable for each of these categories, because you have the correlation in there. So that's a pretty good way to do this top n per group subqueries. If you give it the right index, you will get extremely good performance. So that's the prime use case I use this for. There are some other use cases. There are table functions. Who's using table functions? Yeah, exactly. Some of you. So there are some other use cases, but the most common use case is indeed this top n per group use case. So how can you remember this? I have tried to give you some hints if you are programming in other programming languages and how these features compare in SQL to other programming languages like Java, for example. I like to compare lateral to the for each loop because that's what it is. It executes the inner query for each row of the outer query. Full stop. It's good and bad. It still plays well with all types of joins. It's great for these top-end subqueries, and that's it. So the question is, can you use that now? It was introduced with SQL 99 into the standard, but the standard is just a piece of paper. Let's see. So I digged through all these databases and tried to find out since when they are supporting that. And as you can see, quite some databases support this lateral for more or less a few years or even decades. But the big exception is MariaDB, MySQL, and SQLite. They don't yet support that. So if you're using these databases and want to use that feature, option number 1, migrate to Postgres. Option number 2, ask your vendor. It's really upon you to make the demand visible to the vendors. Okay. So the next feature I would like to showcase here, still out of SQL 99, grouping sets. Who knows grouping sets? Who would have ever needed to use grouping sets? Yeah. Who would have needed to use grouping sets but doesn't know yet? So it's about aggregations, grouping, group by, okay? And sometimes we would like to do a report, like say here, on a monthly basis, some sales figures. How much sales did we have for this month? And at the same time, we would also like to have the super aggregates on a yearly basis, okay? Of course, we can do 2 queries, no problem. Run the first one, run the second one, you have both results. You could even, because SQL is composable, you could even combine them into one, put a union all in between, and then you will get all the results in one run. Of course, it will still execute the first and the second. It won't get faster, but at least it's one result set. And here comes grouping sets. Grouping sets give you the exact same result, but faster and easier. You can now in the group by clause say, I don't want just one aggregation, but I would like to aggregate for grouping sets. And you can list grouping sets, as many as you like there. So you can say, I would like to have it on year and month, and then again just on year. And this will give the same result as the left-hand side query. It's just faster and less typing. So that's grouping sets. So who would have needed that in the past? You see? So it's as simple as that, multiple group bys in one go. You can even do a group over all the rows, which is the empty brackets. So you can say grouping sets empty brackets, that means over all rows. You can even data mine, if you get a row, you can find out to which grouping set that row belongs to. There are some meta functions to get that out. And there are some aberrations, like rollup and cube, which is for rollup, I have written it here. So ABC is basically ABC, AB, A, and the empty set. This is just a shorthand. That's it. So can you use that yet? And the surprising answer is, yeah, most likely. So MariaDB and MySQL only support rollup, but that's at least a little bit. You can still filter out what you don't need. And it will be faster than doing it in several attempts. And you see this is there for decades in some databases. So these were just 2 tiny features I've picked out of SQL 99. Now I'd like to go on to SQL 2003, which is most probably my favorite release, I think. Because there was one huge feature which is called window functions. Who has ever heard of window functions? Ah, okay. Who's scared of window functions? Ah, same number. So that's the over clause. I will first again show you the problem you might solve with that. The problem SQL 92 had is that they intermingled 2 distinct concepts. The first concept is merging rows that have some properties in common. You can do it either by distinct or by group by. And the second concept is aggregating data. You can do this with group by and some aggregation functions. And they are related, unfortunately, in SQL 92. I'll show you in a matrix view. Let's start with a simple query, 2 columns, 1 row, just everything. And on this axis, I will say if this query is merging any rows. And of course, the upper one is not merging any rows. But if I want to get rid of duplicates, for example, then I can just put in distinct there. And rows with the same values in all columns will be merged. On the other axis, I'm now adding an aggregate. So instead of just filtering duplicates, I'm now doing some sum. and group by some other columns. So I guess you all know that. The question is, what about the white spot? Easy. SQL92 is composable. So we start by taking just a plain figure. And if I would now like to add the aggregated data, the sum, without actually losing any rows, then I can easily do that. I just need to join the down query here, put it there, and here we go. I can now select this value. And it's really the beauty of SQL. Everything is a table. The result of a query is a table. You can query a query like it was a table. It's so beautiful, and I can clearly see in your faces. You see that. It looks basically like this. Of course you can do it, but it's no fun. Okay? And yeah, it was you. I think it's good to see SQL92 as something scientifically driven, and from 99 the industry took over and made handy solutions for common problems. Okay, and here comes the over clause. So if we want to select all the data and just enrich it by some aggregation without doing group by, we can do that now. We put in here just one more column, and this column shall be an aggregate, and the rows that it shall be aggregated are defined in the over clause. I will show it this in detail. Imagine a query and a result. And it all starts with the almighty comma, because the only thing I'm going to do is adding a new column to this result set. And if I want to do sum, then I just use the aggregate function sum. I can also use min, max, whatever you like. And if I don't want to put a group by clause, I have to use an over clause right after the aggregate function to specify over which rows the aggregate shall be calculated. That's it. Empty over clause is valid, which basically means over everything, very much like in grouping sets. So you get a total of 6,000 in this case, because 6 times 1,000. But you can also segregate the result like we did with group by. So just summing up the values which have some common values. And instead of group by, it's called partition by. But it's basically group by. So if you say partition by department, then you will get this segregation and you will get these results. So that's the basic foundation of what is window functions. But that's just the basic foundation. It goes on. The next thing is the framing and ranking. Funny enough, in this over clause you can also put an order by clause, which doesn't make so much sense if you think of aggregate functions like sum or min or max. It basically doesn't matter if you make 1 plus 2 or 2 plus 1. So this over is not about really sorting it, it's just about another way to tell the database over which rows to aggregate the results. I'll show you an example. Query result. It's banking transactions, like depositing 10, taking some deposit, something in, something out, okay? And what we want to accomplish is to know the balance as of each transaction. So how can we possibly do this without these window functions? Easy. SQL is composable. So one of the possible solutions is to just write a Scala subquery in the select list and do the aggregation there, just everything up to including this transaction. It works. Not fast, but it works. Okay, it's composable. But this is another case of where I would actually like to do some aggregation without group by. But what I've shown you so far doesn't solve that problem, because if I'm using this partition by, it only segregates by same values. But what I have here is a less than equals condition. I cannot translate this into a partition by clause. And this is what we have the over order by clause for. So we want to make a sum over. And then we define an order for the sole proposed reason about which rows shall be aggregated. And once we have established an order, we can use the framing clause, which reads, for example, rows between unbounded preceding, which means the very first row, and current row, which happens to be the same for the first row. So it's just summing up one row, result is 10, that's just fine. But for the next row, unbounded preceding is still the very first row, and the current row is another one. And all of those between will be aggregated. And here we go, and we have our running total. Okay? Who would have needed that? I forgot just some detail. These transactions don't belong to the same account. So I just made something completely wrong. So if I need to still segregate by some account number, I can still put in the partition by clause just to segregate those data again. So this is not exclusive. You can still put in partition by and over. All of that is possible. So this was the framing. And the last feature introduced with SQL 2003 in the window clause, window function area is ranking. So this is like numbering rows. So now we finally have row number. So we can now finally officially SQL compliant way say number 1, 2, 3, 4, 5, 6, 7. And there are even more of them, like ranking, dense ranking, which means how to cope with ex aequo positioning in sports. Is it rather first place, third place, or is it first place, second place, if they have ex aequo ranking in the first two? So this is the ranking cluster of functions. So what are the use cases for this overclause? Aggregates without group by. Whenever you have you want to do an aggregation but don't want to do a group by, go for over. That's it. Running totals, moving averages. Yet another example. You can say rows between 3 preceding and 3 following. That's beautiful, huh? Ranking, top n per group. Again, another way to implement top n per group is to number the rows where you use the partition by clause to group, and then you filter on those you are interested in. Self-joins. Who is doing self-joins? You are doing it wrong. Self-joins are mostly dead. If you're doing self-joins, you're most likely doing it wrong. Think about it. The overclause is one of the prime ways to avoid self-joins in modern SQL. And there are many more use cases. You cannot possibly enumerate them. So what is it in a nutshell? Over may follow any of the well-known aggregate functions, min, max, count, average. You basically define which rows to aggregate on. Empty overclause about everything. With partition by, you can segregate like group by, and if you do an order by, you most of the time do it just to reason how to define the rows that shall be aggregated. So can you use that yet? Yes. Almost. You see the flip-flop there? It's arriving. It's arriving. It's arriving to MariaDB and MySQL in the next major release. So that's MariaDB 10.2 and MySQL 8. It is coming, as far as I know. Disclaimer, you know, I don't know anything. So yes, you can use it. And it's one of the most powerful features of SQL. It's so powerful that it's even made it into NoSQL databases. Okay? So that was window functions for the time being. Next feature, within group. Who has ever heard of within group? Oh, at least. So what's the most common use case for it? Like median, the middle value of a set. Okay, how to do that in SQL? Have you ever tried doing the median, the middle row of a set in pure SQL 92? Yeah, you failed probably. Yeah, me too. So I think this is a correct implementation. What it does, this is pure SQL 92. It's really just relational algebra. So what it does is basically numbering rows by doing a self-theta join and then picking the middle row. Isn't it beautiful? Look, it's not even a self-join. It's 3 times accessing the same table. 3 times, okay? So the only possible answer to that is no. No. Thank you, scientists. This is not the answer we were looking for. So we have now something more beautiful like this. So it's an aggregate function, kind of. Percentile disk in this case, 0.5 means the median, the middle value. If you put in 0.95, then it's the 95% percentile. And then you say within group, order by that value, which also implies which value to return, basically. And that's it. You can now group within group. It's just what the name says. There are even other functions, like hypothetical set functions. I've never had a use case for that. Like, if I would insert the value 1, 2, 3, which position would it have? Yeah, it's there. Can you use it? Maybe. So who can use it according to this scheme? Who's using a database which has already support for what you see here? Oh, that's not so many. Okay, so this was just a few selected features out of SQL 2003. The next one, SQL 2008. I must be honest, I've skipped one, SQL 2006. It's just that I don't like that too much. And the first feature coming with in this presentation now is something you have already used, just in a different form. I even had it in the slides in a different form. But now the standard has a defined form. Fetch first. Who is using limit in MySQL or the like? Who is using row num in Oracle? Who is using top in SQL Server? Yeah, you're using basically this. But these are all proprietary extensions to implement that. And now we have a standard. However, even before this feature was introduced, you could already do it with window functions. So you can basically just number the rows and then cut it off. And commercial databases are even good at optimizing this query. Nevertheless, it's a lot of typing, and most people just say, oh, come on. Let's take limit or top or whatever. And now we have fetch first 10 rows only. It's just a few less keystrokes than the window functions, but that's now the official way to do it. So can you use it? Yes, kind of. So green in this chart means yes, you can use it, it works. Go ahead, fetch first, that, rows only. Yellow means there's something that is equally easy to use, like limit or top or so. Every database has solved this problem. But the green ones are now standard conformance, which means they support fetch first, blah, 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 row only. Is it important? Yeah, kind of. Okay, so this was just one selected feature out of 2008. SQL 2011. Now we are coming to the fun parts. Believe it or not, SQL 2011 introduced the worst SQL feature ever. Who is using offset? Who is using offset but knows there's some trick question here now going on? Yeah, okay, oh, even. Yeah, so I'll show you first what it does. So even without offset, we could accomplish the very same. So one common use case of offset is to implement pagination. That means if you show the first 10 rows to a user, and the user wants to see the next 10 rows, then you can say offset 10, and it will just skip 10 rows. You could also do this with a window function again, and just use the correct where clause for that. But now you can say offset 10 rows, and watch out, fetch next 10 rows, not first 10 rows. Fetch next 10 rows. I think that the committee gets paid for each keyword they introduce into the standard. There's no other way to explain that. So this is now fully standard conforming SQL, and you could use it. And I see your faces, and you see my face. And I go like this. No, don't use offset. So I think the coasters are already gone outside. But there are stickers too. Are there still stickers outside? Yeah. Okay, so grab the stickers. The URL, which is also written here, is also written on the stickers. It's usetheindexlook.com/no-offset. So in a nutshell, what's bad about offset? First of all, it's giving you the wrong result, at least in most cases, because offset always renumbers the rows at the time you run the query. So if you fetch 10 rows, and while the user is looking at these 10 rows, some insert happens in between, and then he pushes next, the renumbering starts, and everything is shifted down due to this insert. Have you ever had the effect that the last row of the one page happen to be the same as the first result of the next page? Yeah, they are using offset. Okay, so offset is giving you probably the wrong result, at least for the use case pagination, unless some special cases, like if you know there is no insert, then you get at least the right result. Then you will only suffer from the second problem of offset, which is that it's slow, because it will always renumber the rows from the beginning. There is no other way to do it, except, of course, as explained on this website. So don't use offset. Nevertheless, it is standard now since a few years. Can you use it yet? Yes, you could, but you should not. And if you have looked at these slides very carefully, you might have noticed that there was not a single slide where all these databases went green yet. And in fact, this is the only slide where all these databases are green. And it's something I can really not recommend to use. Except there's the only valid use case I know for offset so far is to implement sleep in SQL. So if you ever need that, go for offset. Okay. If you need it. However, we have already heard about window functions before, the overclass. With 2011, they were extended. I'll show you again some problem and how to solve it without the new feature, and then I will show you how to solve it with the new feature. And the problem I'm showing you now is the opposite of the transactions we had before, not the running total. It's not that I have the transactions and want to have the sum up till there. It's the opposite. I do have the balances, and I would like to know the difference to the previous row. Okay? So let's start again. Simple query, simple result. First of all, always a good idea, number rows. This has never been a bad idea. Just let's number the rows. I just noticed that the with clause. Who knows the with clause? Okay. Just imagine this is a few. Okay. I skipped the with clause today because I have some other features in there later on. But this is basically just a few. So in this few, which has the name number t, I have the table itself plus the row numbers. Now I'm selecting this and I call it current from this table. And now I'm doing a self join. We don't do self joins anymore, okay? But for the example, we are doing a self join. I'm doing the self join by offsetting those rows, one next to each other. And now I have this and the previous transactions next to each other, and I can just do the trick to subtract the one from the other. I have to take care of the first 0, null, there, and then it's done. It's perfectly valid. It works. It's not the honestly, it's not the worst way to do it, except that this one is better. So there's now in the core list there is now a window function lag used, and it's really just lagging behind previous row from this result set. You have now means to access other rows of the same result. Lag is just one example. That means the previous row according to the order by clause in the overclass. That's it. You can directly access the previous row. Besides lag, there is of course also lead, which means the next row. You can also give offsets to them. It's just not the next row. You can also ask for the second next row and so on. You can also ask for the first and last one and the third one and whatever. You can ignore nulls if you like. Okay? That's also a very powerful extension to window functions. So can you use it yet? Maybe. Maybe. Okay. Next feature. Time traveling. Who would ever have used or who has ever implemented time traveling in databases? Yeah. The other ones just don't know it. So what is it about? The technical term is temporal and p-temporal tables. It's not like temporary, it's temporal. It's more like in Star Trek. If you know Star Trek, they don't have temporary anomalies. They have temporal anomalies, okay? It's about time. What is it exactly? The problem SQL had is that it's destructive. If you're updating some data, you are basically overwriting it. The old data is gone. And this is not always what you want. Sometimes you need to keep track of your changes. And this is what this feature allows you. So as of SQL 2011, you can start declaring tables to be system versioned, application versioned, or both of it, or neither of it. I will show you system versioned here. And system versioned basically means system in terms of database. Please take care of the versioning for me. I don't want to have to do anything with that. Just do it. And this is how it works. It's declarative. So at the time you're creating the table, you can of course also alter it afterwards, but you're basically adding two special columns, but you have to add them on your own. So you have to give it one column which marks the timestamp when the row was inserted, and another one which marks the timestamp when the validity of the row was gone, when it's ended. And you have to say generate always as, which means database, please fill it for me. Generate always as row start and row end. Then you combine these two columns into a logical unit called period. Others call it interval. In SQL we call it period. So we say this is now an interval from here till there. And then you just say with system versioning. And bam, you're inserting something, and the database takes care to populate these two magic columns, because you said generate always add. And if you're then updating it, it's not actually updating it. You will have two rows afterwards, and the values will be properly set according to system time, because it's system versioning. And if you delete it, it's of course not gone, it's just set the configuration. And if you query it, you won't even notice, because it's system versioning, it's transparent. Your application doesn't need to be changed. It will just see the current version, unless you ask for some other version, which means you basically say after the from clause, after the table name in the from clause, you say as of that time, like 3 hours ago, and then you get it. Unless you do that, it's completely transparent. Yeah, that's an excellent question, which is answered in the third slide, I think. So the question is about the primary key. And this is also, this was system versioning, okay? There's application versioning, which means the application has to take care of setting these values correctly. For example, a booking system or something they like. If you look here at the red circle, you will notice there's an overlap. If the one starts at 9 and ends at 11, and the next one starts at 10 till 12, there's an overlap. This must not happen. This is the problem we have here. And SQL 2011 has a feature for that, because now we can define the primary key to not only consist out of the actual key value, but we can also say for this period without overlaps. One moment, please. Now I'm gone. Yeah. Is this answering your question? Okay. So this complete cluster of temporal databases is really incredibly huge. It was one of the biggest additions to the SQL standard since '92, I would say. This is just a teaser. I can highly recommend this paper here. It's maybe about 10 pages, and it's really an excellent read to learn about these temporal features in SQL 2011. So if you're interested in this feature, go and read this paper. So can you use that yet? If you're running on a commercial database, yeah, maybe. So you can see many databases are adding this recently because there is demand for this feature. Who would have use for this feature? Yeah. Basically everybody, because as soon as you have customers, you usually need to track somehow, like when they move or when they change their name and so on. Everybody has. So the commercial databases have this in their portfolio to a more or less complete extent as of now. So this was time traveling and SQL 2011. Now we are coming to the latest release, and surprise, surprise, 2016. It was released December 2016. It's still warm, okay? And I've picked two features to showcase you here. The first one is match recognize. Who has ever heard of that? the official name is row pattern matching. Okay, so what is it about? Imagine a log file, like a web log file or anything like that, an event stream, it doesn't matter. And you have a time axis and the events are coming in. Okay, so let's say a web log file. And you want to do some analysis on that. For example, if we define a session to be, let's say, 30 minutes, or let's more precisely, everything that a session is continuous as long as the one event happens less than 30 minutes after the previous one, then we would end up here with those sessions. And we would like to put them together and do some analysis on that. I will just do a very simple analysis, like doing the average duration of a session. How can we do that? We can use it with the row pattern matching, which I will show you right now. And we can, of course, also do it with window functions, which I will show you afterwards, just to scare you. So, this is the query. And in the great tradition of SQL, a great tradition of SQL is that it makes more sense to read the queries this way than this way. Okay, so let's start at the bottom. So what we are doing here is we are defining so-called pattern variables. And a pattern variable is basically just a condition. Like here, the condition reads, if the timestamp happens to be less than the previous timestamp plus 30 minutes, then it's true. Then it's continuing the previous session. So this is the how I define the session here. The next one is the pattern clause. Who knows regular expressions? No kidding. This is basically regular expressions. It's just a light version. It's not fully fledged, and it does not operate on characters, but on rows. So this regular expression is using, says match one row which qualifies as new, and then match as many rows as you like which qualifies as cont. And here's one strange thing. If you use a pattern variable in the pattern clause which is not defined in the define clause, then it matches any row. So that basically means match any row and then as many as qualify according to the define clause. So the next one is basically saying, okay, and now you have a match. A match can be made out of one row or maybe a million rows, I don't know. It's as long as the session goes on, as many matches it will match now. And each of these matches, each of these sessions, can then be condensed into a single row if I want to. This is basically like group by, but not using on same value, but on these matches. So I can say, hey, from the matches, out of each match, condense it into a single row. Then the measures clause is basically what we use as select, as the projection. There we say which columns we would like to have. And we can now access these things like similar to window functions. We can say, I would like to take the timestamp of the last hit of this session, subtracted from the first one, and this is the duration of this. And this will be then the result of this match recognize clause. So that's one row per session. And if I want to have the aggregate session, if I want to have the average session duration, I just need to take the average. That's it. Okay? So now let's try using window functions. So here we go. Just quickly skimming through it. First of all, it's doing the so-called start of group tagging. So it's identifying the first hit for each session. So that's basically highlighting the first ones there. After that, I'm numbering the sessions by counting just how many of these markers I have there. And now it's easy because now I have something I can group by on, the session number. So I'm basically just doing the group by session number. Then instead of min max, instead of first last, I'm now using min max to get the first and last timestamp to do the duration. And then I can do the average. So I have here 4 levels of queries. 4 times nested, 4 times select, as opposed to the previous one. and I can tell you this one is not faster than the other one. Okay. If you want to know more about row pattern matching, I have a separate set of slides where this and many more examples are in there. Just go to SlideShare and look at my account. There you will find these slides. So this is one very, very interesting feature. I would say my favorite feature out of SQL 2016. Can you use it yet? Who can use it yet? Oh, not so many. So which databases are you using? Mostly MySQL? Who is using MySQL? Okay. Postgres? SQL Server? Oracle? Yeah, it's pretty evenly distributed. Great audience. So afterwards then, okay. My bet is on Postgres. Okay, this was one feature out of SQL 2016. Another interesting feature, which every single person in this room would have needed to use before, is list egg. What is it about? So if you have something like this, and you want to basically do a group by, but a group column, and you would like to get a comma-separated list of values, go ahead, do it. You can now say list egg. This value column, you specify the separator. You say within group order by, because you probably want it to be in a well-defined order. It's again this within group, and you will get out this one. It is like group concat in MySQL, just better. Because there's an overflow clause. So if you're aggregating a lot of stuff, the string might become very long, maybe longer than the longest data type supported for strings. And then an error might happen. So this is the default behavior, on overflow error. But you can also say on overflow truncate. Just ... who cares anyway? Okay. And the default is also that if you do truncate, then you won't add a count. But you can also say with count, which will then basically say, hey, I've skipped 1, or 7,000, or whatever, in brackets. Okay? So can you use it yet? Do you see the very little tiny green part at Oracle? So Oracle 12.2 was released for on-premises installation just 10 days ago. 10 days ago, and Oracle 12.2 can fully do what I've shown you on the previous slide. Before that, it did not have the on-overflow clause. Otherwise, it works. And you see pretty much everything is yellow here because it means it has something that is easily to use, like group concat in MySQL, or string egg in Postgres. SQL Server is the only one still red, but on the next release, they will have string egg in the vNext. So pretty much every has it in some extent, but now we have a standard way to do it. And the standard way to do it is list egg. That's the way it is. Other topics in SQL 2016. JSON. Who uses JSON in the database? Yeah, I will make some of these with JSON. Date formatting. It's a tiny little thing that there is no standard conformant way to pass date formats and to format dates as string. Now there is. And finally, there is polymorphic table functions, and I have no clue what this is about because I did not read that part of the standard yet. Encrypted rows. Oh, now I'm scared. Okay. Yeah, I think so. It's polymorphic and pretty meta topic, I think. I'm not so keen to investigate it, I must admit. Okay, so this was my small selection out of 1,700 pages ISO SQL part 2. The ISO SQL standard consists of something like 15 parts. This was just part 2. It's just a selection. But to be honest, I bet, let's try it. Is there anyone in the room for whom there was not a single use case he would have needed in the past without knowing it about? Or is nobody admitting it? So I think everybody has something to take away from this, and you can use it. And SQL, many people like to describe me as I'm a relational database guy, and I'm not. I'm not. I'm SQL guy, because SQL is beyond relational for decades now. We have more than relational. Relational is fine in many, many cases, but not for everything. And it's not that SQL has ignored it. No, they adopted to it, like 20 years ago. So let's use it. It's there. It's working in many, many databases, and it can make your life much easier. So much about that. So who am I? That's me also. I make my living from training developers to make good use of SQL databases. What a surprise. So that's mostly indexing and modern SQL, as you have just seen. But more importantly, I'm running this website. Who knows usetheindexlook.com? Yeah, that's my website. And this website was later on turned into a book. This book is called Sql Performance Explained. Who knows this book? Okay, and who knows the big secret about this website and this book? Yeah, the big secret, it's the same content. What's the difference? There is none. Well, there is one. The website is for free. The book costs you a few bucks. The content is the same. I would even say on the website you have a little bit more, and it's a little bit more recent, although the printing book is also updated regularly. But it's really, I'm happy if you buy it, but it's not an excuse like, okay, I don't buy books, so just go to our website. And in the meanwhile, 2 years ago, I started a new website. What a surprise. Modern SQL. You will find everything I've shown you here. The slides are there. The slides are there even with the features which I have not shown to you right now because of time constraints. It's about twice as many features as I've shown you here. So go there, study it, and subscribe to the blog. You will get just free emails again, free. There is no book yet, but there might come one. And yeah, I invite you to explore modern SQL and the idea that SQL is not stuck in the 90s. So thank you, and if you have any questions, I still have some minutes, I think. For the window functions, I have it somewhere in the slides. Yep, for over. Yeah, it's a very strange thing that most. So the question is, how about non-relational databases? And if I look into them, because they are starting now to add something that has some QL in their name. I think, as far as I can say, those NoSQL vendors that are now adding some dialect of SQL pretty much ignore the standard. They do their own thing for whatever reason, because maybe they don't know about it. I've seen many presentations of these databases, not exactly these, but some of them, that now introduce some features in different syntax as standard SQL, although standard SQL has a solution for that problem they are solving. It's okay if you have to invent something new if SQL doesn't have a feature for that. But SQL has a feature for many, many things. And I think if you're doing something that looks like SQL, then you should try to stick it as close to SQL as possible. And the NoSQL vendors are not doing that, unfortunately. Yeah. So the question is if I have used temporal tables in practice, and if there's a performance impact. The answer is no. The simple reason is because wherever it was needed, it was already implemented manually. I would recommend, if you have a greenfield project where you need this feature but you don't have had the effort of doing it on your own before, then I would definitely go for it. I have not done any detailed performance analysis, but The problem is the systems which I used to work with are legacy systems. They have solved it on their own, and there's then no reason to migrate it to that. But if you have a greenfield project, go for it. At least consider it. Let's put it that way. Safety net.